So what I want to talk about today is about some activities that I've performed with my students along the past several years that all involve community engagement and science communication. That's something that all through my career teaching physics in different institutions, different kind of institution and levels, that's something that I think it's quite kind of like a responsibility that we have that we're teaching the contents of physics, but at some point, I think that I like to stress the importance and the relevance of how we communicate what we do with society. And that's something that also, on the other hand, well, students at some point, they need to communicate whatever they are doing. It could be their research or their project or whatever it is, they have to communicate in different venues. And that's something that I've tried to accomplish through these activities over the years. So um, if the magic of technology allows, or if not, I can always just click. But it used to work like half a minute ago, but it doesn't. But I can always click on the buttons of the laptop.
It should
And
work
will be
now.
fine.
Let me just.
So typically, maybe one of the visions that people have of society.
Let me just.
Oh, yeah, it works now. Thank you.
You're right.
So is that, oh, the scientists, they're living there in the ivory tower and they think they're kind of like superiors. They don't want to merge with society. And I think that that's wrong. It's not just wrong, a wrong perspective, but that's not true. I think that we really want to communicate what we do. And I think that we traditionally have not been good at doing that. And that's why this image of the ivory tower and the scientists there is spread out in society, and Hollywood hasn't helped us at all. So, but at some point, our students, science students, engineering students, they're going to be doing things like this. They're going to be writing scientific or technical papers. They're going to be writing technical reports. They're going to be presenting posters at conferences, and it doesn't matter if it's like a research conference or just a technological or on an enterprise conference or presentations. They will do presentations at work meetings for sure. They might be selling some products in some company like biotech or any engineering products. They might be interviewed by the media, and they might at some point talk to policymakers. So those are things that our students at some point are going to do a few of them. So, but I realized a few years ago that we're not training them to do it. As a matter of fact, the first time I had to present a poster, they said, okay, you're going to go to that conference, you have to present a poster. And I said, well, how do I do it? Nobody had ever taught me how to present a poster. I said, well, I just try to find other posters and see, let's see from all of these posters that I can see, which one catches my eye and say, oh, if that's interesting to me, maybe it's because it's well crafted. I will take that one and I will move from there. I will make it mine. So, and that's why I started to do these activities with the students. And you know how there's like a gremlin, right? Is that what they used to say about when things start not to work for some reason? Which was, oh, there it is. Is it? No, this one.
Just a sec.
What's what?
I think it's just. If you could just click here.
Oh, oh, just clicking with the mouse. Okay, fine.
It needs an input from the mouse to resume working, basically.
Okay,
So
good.
if you
Thank
see that
you.
it doesn't, just click and then it
Okay, nice. Okay, hopefully I can make it in 20 minutes. So then the activities I have designed with my students are, for example, poster presentation. I have had them present posters at some venues. They have created educational YouTube videos. They have done some teaching activities, having my university students and take them to high school to do some teaching activities. I have had them write opinion letters to the editorial of local newspapers. I have had them write and present to discuss to support a specific idea to policy makers. And then now what I'm working on is they're preparing a stand-up uh, comic presentation related with science. What we're doing now, which is relativity and quantum. That's not that relevant, but it's science and something abstract. Because I think that society, fortunately and unfortunately, we have plenty of information, but plenty of misinformation. And we really, I think that we have the responsibility to make sure that society sees science as something that is in their lives and is relevant and important, because otherwise we can have like flat earthers and anti-vaccine people, or people that think that 5G is going to kill us, and then we can have like an increased number of missless cases in the recent years, and for a reason. So it's not just an activity to have the students gain some skills, science communication skills, but also it's a community engagement where we reach out to the community and we share the science with them. That maybe that some communities haven't had the chance to really talk to somebody that knows a little bit of science. So, poster presentation, I don't know, for outreach activity on relativity. I was teaching relativity. That was in an engineering school. Students were going to be engineers. And I organized an outreach event at the local museum. And that outreach event was kind of like, I wanted that to be like a conference. So I had speakers, and we had a coffee break, and we had some activities, and we had poster presentations. So my students, and it was like an outreach event on relativity. Everything is about relativity. And my students were given, I gave them some problems to solve, and they had to present those problems at the conference. So I had like 45 minutes of coffee break and posters so that people could go and check the posters of the students. So the people, the audience of that outreach event, they are not scientists, not related with science, but interested in science. Otherwise, they wouldn't spend side of the morning listening to other people talking about the universe and time dilation and things like that. So these are just two examples of two of the posters that they crafted, and they had to explain that to the audience in order to know, to have some feedback from how the activity went, other than just talking to the students and to the audience of that conference. First, what I had is I had other faculty from other universities to come to my lecture and deliver speeches in a outreach way, so in a level that everybody could understand, so that my students would listen how to address to an audience that is not a university audience. And I had the students, and then I wanted some feedback from my students, so I had some questions that I shared with my students to see how they were perceiving that particular activity. See if they found it relevant to have people come to my class to talk about something completely different, slightly related. For example, I was teaching relativity, and I had one person that had been working at a nuclear power plant to talk about nuclear fission in a way that everybody could understand. So this person that I chose, for example, is a person that it goes to museums and high schools to talk about nuclear energy, and came there to talk to the engineers in a plain level, so that the students would see how they should be addressing the poster, because the audience was going to be like that. And then I had another survey that I gave to the audience attending the outreach event. So these were questions that people attending that event had to answer about the posters. So how were the posters crafted? And I mean, the feedback was positive. I only did this particular survey once, so I would have liked to go further and collect more information about different times, because that outreach event has been going on for 20 years now, every single year. So I could have done that more times, but then, well, I just moved to a different university, different city, so I couldn't really keep track of that. But so, well, here, question 8 had to do with group work, and in that particular venue, it was like individual presentation, so there's no answer for that. But for example, I was asking to see if the communication items on the poster were conveying the message. So if the people that didn't know about physics, if they could see that the poster was clearly presented, and for example, does the poster reflect the work, or also questions about how my students were answering the questions to see if they really were addressing what the people were asking. So the goal was have a poster. You have to make sure that the people understand these problems, and these problems are kind of abstract. So there are paradoxes in relativity that took a lot of time to really understand them back in the 40s and in the 50s. And there's every few years there's a new paradox that surprises, and it's hard to understand, but they worked the math and they were able to explain the concepts to the audience. This other activity that I started a few years later was let's create a educational YouTube video, which has several goals. First, the students need to understand a very specific concept and explain it in less than 5 minutes. Be able to convey it in a YouTube environment, so it has to be plain language. And also, well, we're putting it on YouTube because it's open access to everybody. So it's like we are sharing that with the world and see if anybody finds that and that finds that interesting. That's fantastic because it doesn't just stay in the classroom. We put it on there on the community. I gave my students a rubric of what I wanted them to focus creating that video. Some of them were like more technical of how and I spent an hour and a half talking about framing and vocal and titles and scripts and things like that, more technical aspects of video making. But then, of course, more 55% of the points were about the physics. So, and everything was scaffolded, like every 2 weeks they needed to deliver something specific to me that I would track. So what's the title? What's the concept? What's the physics? Show me the mathematics and make sure that everything is clear and rigorous and correct before you're going to present that. And then they had to create the videos, show that to family members, and then at some point, then we would put these videos on YouTube, and then we would go to a high school and show that to some high school students there and see what feedback they would give about the videos. So this is just, let's see if it works. This is an example. Is it? No. Well, if it doesn't work, it's just an example of the beginning of one of the videos. It's okay. It's a link to a YouTube, but anyway,
If you have the link, I can.
oh, it should be just by clicking on the image, maybe, right?
Wait,
It's okay.
wait.
It's fine.
Ah, okay. There you go.
Okay, there you
Let me just drag it here so that everyone can see.
Volete sapere quanto vale la vostra casa? Magari per venderla? Ci
go.
fare...
Fine. You see,
Well,
I would just wanted to show an example of what they did. They created like they were just drawing on the
in 4 per voi. In 2, Watson. Eh sì, immobiliare.it. 1 vi aiuta a scoprire il valore della vostra casa e 2 vi presenta l'agenzia immobiliare giusta per voi.
Buongiorno,
Immobiliare, Watson.
They show some mathematics, but they explain it. And
Imagine that you're traveling at 60% the speed of light.
What would you look like to someone on Earth?
Dude, it's not
You
really
just look the
working.
same,
okay, it's
right?
fine. It's fine. Yeah, that's not.
No, honestly, I mean,
Anyway, it's fine. Yeah, you just there it is. Okay. So, well, all of these videos are in a specific web page where I have collected all the videos, and some are on relativity, some are on classical physics and Newtonian physics, and some on electricity. So I let them choose the topic, but all through the semester we work on them understanding it and then being able to explain it to a general audience. And then when we went to the high school, I would need the next slide.
yeah.
So when we go to a high school, then we have them watch these videos, but then we send, yeah, that's perfect. So we give
Imagine
the high
that you're
school
traveling at
students some questions, true or false questions, before they watch the videos, and then after they watch the videos to see if there is any effect on those videos. So we could ask them how clearly that if they liked or not the videos, but I wanted to see, well, are these videos useful to teach physics at some point? Because nowadays our students are so used to being with the phone and watching like 3-minute videos that well, is that a venue that the students welcome? And yeah, they do welcome them, but we saw some kind of like impact on the questions that well, before we had some questions and the success of so their answers before watching the video was not as good as after. So there's some learning. And again, this is we did it with 2 groups. So there are 35 students reflected here. So it's not the statistics I would like to show, but that's something that I might be collecting going forward into the future, more data about the impact of how efficient this activity is. But at some point, we could see some impact, other than that the students enjoyed watching the videos and that there was some learning in the process. Not I'm not talking about my students. I'm talking about the students from the high school, and also my students really. One of the things that they really noticed and they didn't expect is, wow, teaching, because so I put them in groups of 5 students, so they were showing, each one was with a laptop showing their video with 4 high school students, and then another group would come and then another would come, so they needed to show the videos like 4 or 5 times and then say, well, this is this like teaching the same concept again and again and again. Well, that's tough. But then they say, oh, I think that I could answer much better the questions of the last group than the first group, because they put that time in reflecting and understanding, and then they started to see maybe the same question again and again, so they could see how to improve the answer to those questions. So they also had the experience of what it means to teach something. Well, so that so the next activity that I had them do is to write a letter to the local newspaper. And that's something that, I mean, usually when you go to an op-ed, it's usually politics or economics or maybe sports. How about science? So science is also that we're surrounded by science. So that's something that we believe the science and we want to communicate. So I wanted them to find a topic that was with electricity and magnetism, find something related to this field that and write it in a way that is engaging, so that someone can just read it just one column, very limited number of words, something that you state what you want to explain it, and say why this is important. For example, why levitating trains might be interested or might not be interested. So they really needed to do some research to understand that particular concept and be able to summarize that in a very narrow, short number of words. So that was a self-reflection problem that I had to do, and then be able to communicate it in a way that anybody reading a newspaper would be able to understand that. So my goal with this was also, well, let's change the language that we're going to be using talking about science. If you could help me with the next slide, please, because I've tried and it didn't work. So that's an activity that, I mean, we sent it to a local newspaper. They didn't publish that, but I mean, but I know that sometimes they publish things fantastic. They publish things like that because they've published something that I wrote, but then we're not lucky that time because the topic was not too hot topic at the moment. But that's something that I would like also to continue with the local newspaper in the little town where I'm teaching now. Yeah, one. Okay. And so what I'm doing now is they're working on a 3-minute stand-up comedy presentation about some topics. This time I'm teaching physics, relativity and quantum, and they're choosing all of different topics from those 2 fields. They need to understand and be able to explain it in a way that is rigorous, the science is correct. Just one single topic, they only have 3 minutes, but they need to do it in a way that is the audience is engaged, it's fun, but they also learn something. And that's something, of course, I don't have any data now. This is the first time that I do it. But I think that the response of my students usually to this kind of activities, I've received a positive response because they are creating something. They are doing something original, something that they own, something that is totally theirs, and they really feel that they are very engaged with all of these activities. And usually they really, and also they get to learn some physics, because if you have, so the best way to learn something is that you have to teach it somebody else, and then you really need to make sure that you really understand. It's at the end of the day, it's also part of it. So with that, yeah, this is just what the people in the library were presented that couple of weeks, in a couple of weeks, in April 2nd and April 1st. We're going to be talking about lasers and other stuff like that. And well, I apologize for the technology, but thank you for your attention.